Hello, I'm Lewis and this is DIY Machines, a channel where I get to share with you awesome maker projects. Today I'm going to show you how to build your own portable Bluetooth speaker with a couple of pretty neat tricks up its sleeve. At the project's core is our main speaker. This one houses all of the smart features of our project. This includes Bluetooth receiver and amp, the lithium ion batteries, recharging circuit. You'll also find a standard USB and USB-C port for charging your other devices. We can also use these ports to power the built-in portable disco light. This is where it gets cool though. Assemble yourself a second speaker for increased loudness, and it's connected by simply sitting it on top. The embedded magnets hold it into place securely, whilst the Pogo pins form the automatic electrical connections. So, why did I design it like this? Well, you can put both speakers facing in the same direction for increased loudness and stereo soundtracks. Place them at 90 degrees and you increase the width of its soundstage, or back to back for when you're placing the speaker in the middle of a group of friends. Just don't put it too near the sea though. This one I've designed after everybody's favourite plumbers, but don't worry, I've also included the STLs to 3D print a more dialed down design if Italian servicemen isn't your thing. I'll explain in detail how you can build your own Bluetooth speaker, and towards the end of the video as a bonus, I'll also show you how to add this disco light pipe. This video has been sponsored by PCBs. I'll tell you some more about their services later in the video. Lithium batteries are very dangerous if not treated correctly. They can pose a significant explosion and fire hazard. Please consult a professional before attempting the following. With that said, if you'd like to build one of your own, you're going to need just a few components. Below this video, I have put a detailed part list to everything on Amazon you'll need to build one of your own. And to make things even easier than that, I've put together this kit of parts which you can find on my international Etsy shop. Every sale of one of these helps support the next project, so if you go down this route, thank you. You're going to need a BMS, a Bluetooth amplifier, a constant current buck converter, 2 Pogo pins, some bolts, power connector and power switch, a battery holder, a voltmeter, some 12 by 3mm magnets, 4-inch full range speakers, a power supply and filament for the 3D printing. You're also going to need 3 18650 lithium ion battery cells. Get these from a reputable source and don't just go out on the internet and buy the cheapest ones that you can find for your own safety. I have also designed this PCB to help make the assembly of the electronics considerably easier. The first part to 3D print is the main housing of the speaker. This part has been designed to print without any supports, but I did add a brim to ensure good adhesion to the print bed. Mine was printed in PLA plastic and I used a 0.6mm nozzle to speed up the print speed. We can then attach a couple of 15cm long wires to your first speaker and then secure this speaker into place inside the housing using the first 4 of your bolts. The various modules in our project are held together using some magnets. Now, you don't need to use the magnets, but it holds everything together really nicely and has a really quite wonderful and magical tactile feel. To prepare the magnets, mark the same pole with a permanent pen on 8 of your magnets, like so. We'll then glue the first 4 into the recesses of the main housing with their dots hidden inside the print. We can then 3D print the second speaker's housing and then add 4 more magnets to the inside bottom of the print, with their dots showing this time. This is the side with the protruding feet on it and the recess for our PCB later. Whilst we're 3D printing and gluing things, we can print out the optional question mark elements and glue these to the 2 sides of our 2 speaker enclosures. Now, I used hot melt glue to hold my magnets in place, but I'm going to use super glue for this. This is to help ensure that it sits flatter to the side of the speaker housing. Set aside the box without a speaker for now, whilst we concentrate on the main module. Print out the rear panel, and then insert the DC barrel connector, switch, and voltmeter like so. With the rear panel of our main speaker assembled, we can move on to some of the electronics. Now, I've created this PCB which will make wiring everything incredibly simple. You can follow the links down below to buy one if you wanted to. It drastically cuts down on wiring and holds everything in just the right place. Of course, if you don't want to use the PCB, you don't have to. I've put a wiring diagram with a link down below which you can use to create your own circuit. Now, our PCB actually has 3 separate circuit boards on it. You can use a small saw like this to cut down through the thick white lines in both corners to create the 3 separate PCB circuits which we're going to use. The first component which we will add onto our PCB is the battery management system, also known as a BMS. Align it with the pads as marked on the PCB and the BMS. Apply plenty of heat from your soldering iron and then melt your solder into the solder pads, ensuring that it's sufficiently hot to flow well to both sides of our board. The battery holder is then inserted on the other side, aligning the positive and negative ends. You can then flip the PCB over and solder it from the same side as the BMS. Flip your board over again and position your Bluetooth amp, and then solder this from the first side. Connect the wires for the voltmeter cable and switch to the appropriately marked points, paying close attention to the positive wire of the voltmeter. The next part which we can add to the PCB is our step down DC to DC converter. Now, this needs to be of the type where we can set a constant voltage and a constant current limit. This is so we don't mischarge the lithium ion cells. The BMS, which we already have on the circuit board, will protect them from charging to too high of a voltage. However, it's the job of this circuit to limit how much current they can draw at any one point. Before we can solder it to our PCB, we need to set the voltage and current limits on the module. To do this, connect it to your 15 volt power supply using the DC barrel connector, and then grab yourself a multimeter. You'll first need to connect this and set this to measure voltages up to about 20 volts. Rotate this small potentiometer until you get a reading of approximately 12.6 volts. That's the 4.2 volts per cell we want, times by the 3 cells that we have. It can take up to about 20 turns in either direction to go to the full range of the little potentiometer. Now, for setting the current level, you're going to need to check the cells that you're using. On the side of the cell, you'll find some rating, one of which will be how many milliamp hours the cell can store. This is known as 1C. 2C would be at 6,000 milliamps or 6 amps, and a half C is 1.5 amps. To allow myself a margin of safety and to increase the longevity of my cells, I'm going to set mine to output half a C, which is 1.5 amps. We can do this by setting up the multimeter to measure a current and then reconnecting our power supply. And don't worry about creating a short circuit doing this, as the current limiting on our module will kick in, which is why this little red light here has appeared. You can then turn the other small potentiometer until you get the desired reading on your multimeter. Trim any of the lugs on the underside to be almost flush with the board. This can be now positioned on top of the PCB, making sure to orientate it the same way as I have here. Now, I do know it is not the best practice to bridge a gap like this using some solder, but it's going to be adequate for our needs in this project. We can also take the two wires coming from the rear of our DC barrel connector and connect these now to the PCB. Don't forget to double check you get your polarities the correct way around. Following this are the two wires coming from our speaker which we added earlier. These are also soldered directly to the PCB as marked. We're now at the point where we can insert our batteries into the battery holder whilst taking good care to check the polarity as you add the batteries. We can also plug in the mains power and switch on the on switch. You should see a reading on your battery meter, and if you take out your smartphone, you should be able to search for and connect to your new Bluetooth device. Try streaming some music and see how it goes. If everything's working fine, disconnect the power supply and check it still runs on batteries alone. If this works, great. If it doesn't, you should go back and check your work so far against the rest of this video.
Every guy I need to take care of myself, comfort in myself, like a roller coaster.
I also highly recommend that for the first few times when you recharge your new speaker, you keep an eye on the batteries, checking to see if the surface of them is getting too hot to touch, or if you see any visible signs of swelling. We can now prepare our two smaller PCBs for our magical automatic interconnect between the two speakers. Solder the two Pogo pins to the pads on the rectangular PCB, and then to this we can also add two 15cm long wires to the wire points so that the wire exits out the opposite side to the two pins. These two wires are then threaded through the 3D printed male Pogo cover. The cover will only accommodate the PCB in one orientation, so if it doesn't fit for you, try turning it the other way around. The other end of the wires are then soldered to the second speaker. The speaker is then installed inside the second housing using 4 of our bolts. The PCB is held in position using the cover and another 2 bolts. By the way, if your screwdriver is too large to fit inside your speaker to do up these bolts, then I have 3D designed this 3D printable one which holds a little bit driver which you can print to get inside. For the other side of this 2-part connection, we can solder another pair of 15cm long wires to the solder points on our other mini PCB, with the wires again entering from the reverse side. These wires pass through the 3D printed female Pogo cover, which is then held into place again with bolts. The other end of these 2 wires are then clamped into position on our Bluetooth amplifier. They're to go in these 2 terminals here. The main PCB is mounted on the reverse of the main speaker's cover with 4 bolts. This in turn is then fitted to the rest of the speaker housing with another 4 bolts. The volume control knob is simply push fitted on top of the Bluetooth amplifier, and then the battery cover is printed. This should fit nice and snug without requiring any bolts, but if yours is a little loose, this can be secured with another 2 more bolts. And yes, by now you've probably guessed it, the rear cover of the second speaker is also fitted with 4 more bolts. So that's the main speaker system completed now. Just start playing some music on your first speaker, and then to connect the second one, just place it on top.
Show me life, show me love, make it change.
You can of course put them at 90 degrees,
We can wait for better days, but the days
or back to back, and they'll still connect properly.
show me love, show me life, show me love, make it change.
Kinda cool, huh? Don't forget that you can also recharge your other devices using the USB ports on the rear. You'll have to have the speaker switched on to use those. To add some more party vibes to your Bluetooth setup, we can also 3D print and assemble this disco light add-on. But quickly, before I do that, I want to say thank you to the patrons and sponsors who have made this project and others possible. 3D Jake have provided me with the brilliantly reliable and bright filaments which I've used in this project. Thank you. And PCBWay have provided me with the PCBs whilst prototyping this design. You will find a link to this project's page over on PCBWay's website down below this video, which is where you'll also find a link to my Patreon page, which is where this awesome list of super amazing and cool people went to support DIY machines themselves. If you'd like to join them, please consider having a look at my Patreon page. And if you do, thank you very much. So to get started with this funky disco ball, we need to go back to our 3D printer. We'll start by printing the main base of the disco module and its cover. I did these in 3D Jake's wooden fused lumberjake filament, and then painted the grouting areas in black. We can then glue 2 magnets into the rear of the base and a couple of washers on the rear of the cover. I printed the 2 parts of the pipe with green PLA before gluing the light inside the large tube, ensuring its power connection faces out of the pipe's access port here on the side. The pipe and disco light are then glued into place. The USB cable is then attached and passed through down into the base. The 3D printed cable cover can then be glued into position to conceal the cable. If you would like to add some magnets inside the base of your light pipe, then there is space to do this. There's also space to add some to the top of the slave speaker. This way your light pipe will willingly attach itself to just the main speaker or to both when they are stacked up on top of one another. To power it, it's just a case of removing the magnetic back door and plugging in the USB cable to the power supply on the main speaker. Just before we go, I want to say another thank you to PCBWay for sponsoring this project and helping make this video possible. I've been using them to produce PCBs for my projects for some time now and have found them brilliantly quick and really good consistent quality. If you've never designed any of your own before, I promise you it's easier than it seems. I use Fusion 360 to design mine, and you'll find some links down below to the guides where I learned how to design them. Once you've finished designing them, head over to PCBWay where you can upload your design in one simple quick step. You can order 5 PCBs for $5 at the moment. If you're a new customer, they'll also give you a $5 bonus credit, effectively making your first PCBs free of charge. If you're not in a rush, you can get it for some very low rates. But if you need them quick, you can pay a little bit extra and they'll be here in the UK, I've had them in 3 to 4 business days after ordering them, which I think is really quite impressive. So check out their link down below. You'll also find a standard To add some more party vibes to your Bluetooth speaker, we can also 3D print